In this video, we're going to learn how to plot a hyperbola in Desmos, the online graphing calculator. And so to start off, we're going to look at what hyperbolas look like. So hyperbola, the equation for a hyperbola looks something like this. X squared minus y squared is equal to 1. And you can see that immediately we get this graph. It looks like two fans, one opening to the right and one opening to the left. And so one of the things that we can do with this is we can change the sign. I'm going to change the sign that's between the x squared and the y squared to a plus sign, but I'm going to put a minus sign in front of the x squared. So in other words, if we reverse the positivity and negativity of the terms, we can see that that alters the direction of opening of the hyperbola. So when the x squared term is negative, the hyperbola opens vertically. When the y squared term is negative, the hyperbola opens horizontally. So let's go back to our original format. So we're going to put a minus sign between the x squared and the y squared. Okay, and so we're going to explore what happens when we put numbers underneath the x squared and the y squared in the denominator. And the numbers that we're going to use in this particular video are Pythagorean triples. So I'm going to write these. Let's see. Let's choose something red. And the Pythagorean triple that we're going to use is going to be, let me go back. It's going to be 11, 60, and 61. Not quite sure why this is lagging just a bit. Okay, so there's my Pythagorean triple, 11, 60, and 61. And if I square those, 11 squared is 121. And 60 squared is 3,600. Apologize for the sloppiness of my writing. This is kind of hard to do on a mouse pad. Okay, so 3,600. And then 61 squared turns out to be 3,721. And wow, is that sloppy. Okay, but you get the point. Okay, so our Pythagorean triple again was 11, 60, 61. And if we square those, we get 121, 3,600, and 3,721. So in the previous videos, I'm going to close this and move this out of the way. In the previous videos, when we were doing ellipses, we made sure that the largest of the squares, which in this case would have been 3,721, that the largest of the squares has to be one of the numbers under either the x squared or the y squared. But in this case, we're not going to use the largest of the squares. We're going to use the smaller two ones. So that would be 121 and 3,600. So I'm going to put 121 under the x squared term. And I'm going to put the 3,600 underneath the y squared term. Okay, we can't see the hyperbola at this point. That's because we are inside the hyperbola, so we're going to zoom out. And there it is. Okay, zoom out a little bit more. And there we go. Actually, one more stroke, maybe one more. There we go. Okay, so there's our hyperbola. Okay, and the hyperbola are like those two fans, one opening to the right and one opening to the left. Those are called branches. So we have two branches for this hyperbola. Okay, and just like we did for the in the videos regarding ellipses, we're going to plot the vertices and the co-vertices. We're going to also plot axes, the axis that connects the vertices. We're going to plot the axis that connects the co-vertices. So let's go ahead and jump into that. So here are the vertices, 11, 0 and negative 11, 0. So let's plot those. So we have 11, 0. Okay, and the dot appears on the point that we just clicked a moment ago. And the other vertex was negative 11, 0. There we go. There are our two vertices. And let's make them both green today. I guess it's a green day. So click and hold. Try that again. We'll click and hold on that dot there. We're going to turn that green. And let's make this size 15 so that we can see it more easily. Okay, and then we're going to click and hold on the other green dot there. It's still green, and we're going to change that to 15. And there we go. There are our two vertices. Now let's label those. Okay, that is a vertex, which we can label as 11, 0. So that's a nice label. And then the other vertex, which is negative 11, 0. So there are our two vertices. Now we're going to put in the line segment that joins those two vertices together. This particular line segment is called the transverse axis of the hyperbola. And to plot that transverse axis, we're going to write the word polygon, and then follow by an opening parenthesis and a closing parenthesis. And then we're going to move our cursor back inside the parentheses. And then we're going to list the vertices. So this is how we draw a line segment in Desmos. So open parenthesis 11, 0, close parenthesis, and then we need a comma since we're making a list. That comma is crucial. If you don't put that comma between the points that you're listing in the polygon function, then things won't turn out correctly. So we have negative 11, 0. So there has to be a comma in the points on that list. Okay, so let's make that green like the vertices. And we're going to increase that to size 6. There. So that's pretty clearly visible. We have the two vertices, negative 11, 0 and positive 11, 0. And then we have the line segment joining those two vertices. That line segment is called the transverse axis of the ellipse. So the next thing that we're going to do, and by the way, notice the connection between the x-coordinates of the vertices and the number that's underneath x squared. The square root of 121 is 11, and that's where we get these numbers for the vertices. Now, on the other hand, the square root of 3600 is 60, and we're going to use that number to plot the co-vertices. So here are the co-vertices. We're going to have 0, 60, and again, that was the square root of 3600. And then our other co-vertex is 0, negative 60. And let's make both of these points black. And we'll resize them to 15. So we've got to resize the other one as well to 15. And the way I'm resizing those again is to click on that circle that's to the left of the point. I click on that and with my left mouse button and I hold. Okay, so click and hold, and then that dialog box with all the editing features pops up on Desmos. Okay, and then we have to label this point. It is a co-vertex, so CO-vertex. So that's a co-vertex, and again, that was the point 0, 60. And then the other vertex, or co-vertex rather, oops, that is the point 0, negative 60. So we have our co-vertices now, and they are labeled. And then, just like we did for the vertices, we're going to plot the line segment that joins those 2 points together. And again, we're going to use the polygon function to do that. So polygon, then open and close parentheses, put our cursor back between the parentheses, and now we're going to list the points. So the first point was 0, 60, and then we need a comma, and then the second point is 0, negative 60. So we have that is our axis that joins the two co-vertices together, and that axis happens to be called the conjugate axis. So let's edit the conjugate axis, and we'll click and hold, and we're going to turn that black like the co-vertices, and then we will increase that to a size of 6 pixels, or width of 6 pixels. So there we have the vertices and the transverse axis, and we also have the co-vertices and the conjugate axis. All right, so the next thing that we want to do for our hyperbola is we're going to make a box. Yeah, I like to call this the X box because we're going to use this box. Now this box is actually not part of the hyperbola graph, but it helps us to draw the hyperbola graph. And so we're going to end up sketching in the asymptotes. Not sketching, actually, we're going to plot them. And so we're going to plot the asymptotes, but it's really helpful to have the X box in there to help us to do that. Now the coordinates of the X box, we're going to start in the upper left-hand corner, and we're going to use the X coordinate of the vertex and the Y coordinate of the co-vertex. So we're using the X coordinate of the vertex that's on the left and the Y coordinate of the vertex that's up at the top, co-vertex rather, that's up at the top. So the X coordinate of the vertex on the left is -11, and the Y coordinate of the co-vertex that's up at the top is 60. And so there is our first point for our box. Let's make that blue. And we're not going to label it or change its size. We just want to know where that corner point for our box is. Now, the next corner point moves to the right. In fact, we're going to plot our corner points consecutively in counterclockwise fashion. So starting up there in the upper left, the next place we go is to the upper right. So the X coordinate of the vertex on the right is 11, and the Y coordinate of the vertex up at the top is 60. And so there we have our next point, the next corner point for our box. We're going to turn that into blue. Okay, so then the third point, we're going to go down, straight down, so that we're directly underneath the right vertex and just to the right of the co-vertex that's down below. So the X coordinate for the right vertex is 11, but the Y coordinate for the vertex that's down at the bottom there is -60. And let's turn that into blue. There we go. So that is our third corner point, and our final corner point is going to be directly underneath the left vertex again, but again it's going to be underneath, so it's going to be down below on the same level as the co-vertex. That's down below, and so the X coordinate of the left vertex is -11, and the Y coordinate of the co-vertex that's down below is -60. And we'll change the color of that point also to blue. There we go. So there are our 4 corner points. Now we want to connect them together. We're going to draw line segments joining them in exactly that same consecutive order so that they are going clockwise starting from the point at the top. And to do that, what we're going to do is once again write the word polygon, because this is how you make things like rectangles. Open parenthesis, close parenthesis, and using the left arrow key, I'm moving back into the polygon. So what I'm going to do is I'm going to list all of the 4 points, the 4 corner points of this rectangle. I'm going to list them inside the parentheses of the polygon function for Desmos. And I'm going to do them in order from top to bottom, starting with -11, 60, and work my way down through all 4 points. So the first one was -11, 60, close parenthesis, and then we're going to put a comma in there. And then the next one is +11, 60. There we go, and then a comma. And then the next one is positive 11 comma negative 60. Okay, and when we see that triangle, we know we're going in the right direction because the next point is going to be the one in the lower left. So comma, and that last one is negative 11 comma negative 60. All right, so there is our box. Okay, but we're going to dress it up a bit. We're going to edit it. For one thing, I don't want any fill in the box. So I'm going to shut off the fill. So now we've taken out the pretty blue color that was inside the box. The other thing I'm going to do is I'm going to make sure that the lines are dashed. That indicates that this box is not actually part of the hyperbola. So the hyperbola curves are solid, but everything else other than the points are dashed, okay, because they're not actually part of the hyperbola. All right, so we've got that so far. The next thing that we're going to do is plot the two asymptotes, okay, and so the equations of lines look like this: y equals x. Right, now that's not the line we want, of course. We're going to put a fraction in front of x. Now, to get the fraction that we're going to put as a coefficient in front of x for plotting this line, we're going to start, think of it this way. We're going to start at 0, 0, the center of the ellipse, and we're going to go up 60 units to get up to this top point. And then to go to the upper right corner, we'll then move 11 units to the right. So that was 60 over 11. So that's the fraction I'm going to put in front of x. So 60 over 11. And bingo, notice how that line goes through the corners, the upper right corner and the lower left corner of our box. Okay, and then I'm going to change its color to blue to match the box. And I'm going to make it dashed because it's not actually part of the hyperbola, but it is something that shows control of the hyperbola. Right? The hyperbola will never cross that straight line. Okay, now to get the other asymptote, there are always two asymptotes to hyperbolas, and to do that we're going to copy the asymptote that we just drew. To do that I'm going to go Control C or Command C, and then into the next entry field I'm going to do Control V. Okay, and notice that now all of a sudden I have another line on top of the last one that I plotted. We don't want that. What we want is a line that goes from the upper left corner down through the lower right corner. And to do that, I'm going to put a minus sign in front of the fraction. So that is the other asymptote. And again, I'm going to change the color so that it matches the other asymptote, and I'm going to make it dashed. Okay, and so those are our asymptotes. And if we zoom out for just a moment, we'll come back to this view. But if we zoom out, let's say a couple, we see that what happens is eventually the hyperbola gets really, really close to those asymptotes, but it never touches the asymptote and it never crosses the asymptote. It just keeps getting closer and closer, but never touches it. So, and that happens in all four corners of this hyperbola. Okay, they get closer and closer to the asymptote, but it never quite touches. And that's called asymptotic behavior. So we'll zoom back in to our box there. Okay, now the last thing that we have to plot is our foci, or I should say our foci, because that's plural. Okay, and if you recall, we started with the Pythagorean Triple 11, 60, 61. Now we've used the number 11 and we've used the number 60 in our various points and in plotting the box and so forth. Okay, to get the foci, we're going to use the leftover number, which is 61. And so here's a thing that you want to remember, which is the foci are always on the same axis as the vertex. Now, in this case, the vertex is on the x-axis, so that means that the foci will also be on the x-axis. So when we plot these points, we're going to plot them as 61, 0. And we will plot the other one as negative 61, 0. So we use the third Pythagorean triple, and we have those 2 points. Let's make them both red. And we're going to increase their size to 15 so we can see them a little bit more easily. Okay, we'll make this one size 15 as well. Okay, and then we need to label them. So these are the foci. Each one individually is called a focus. So we're going to call this a focus, and the coordinates are 61, 0. So there's the first focus and labeled. And here's the second focus, which is at negative 61, 0. There we go. Okay, and that is our ellipse, or hyperbola, not ellipse, hyperbola. That is our hyperbola. We have the, as you saw, we have the vertices, individual vertex. We have the co-vertices. We plotted the transverse axis. We plotted the conjugate axis. The transverse axis joins the vertices. The conjugate axis joins the co-vertices. We have also plotted the four corners of our x box. I like to call it an x box because the asymptotes make an x that goes through the center of that box. So consequently, it's the x box. And so we plotted those four corner points. And when we plotted those four corner points, we used the x coordinates of the vertices and we used the y coordinates of the co-vertices to plot those. Then we made a polygon out of it, which was how we ended up getting the box. Remember that we shut off the fill and we also caused the lines to become dashed. And we wanted to use dashed lines because those are not actually part of our hyperbola. And then we plotted the asymptotes, and we did that. Remember, we went to the center of the x box and counted up to the top and then to the right to get from the center to the upper right corner. And that's the slope of our asymptote. And it was 60 divided by 11 in this case. And then we copied that and put a minus sign in front of the fraction to give us the other asymptote. And then finally, we used the third number of the Pythagorean triple to plot the foci. All right, so hopefully this is helpful to you in figuring out how to plot a hyperbola in Desmos. In our next video, what we're going to do is we're going to swap the numbers underneath the x squared and the y squared. So we're going to put 3,600 where the 121 is, and we're going to put 121 where the 3,600 is. So look forward to seeing you next time.